Hi and welcome to today's webcast. We're going to be looking at how to model aluminium composite material in Solidworks.
Thanks a lot, Charlie. Good morning, everyone, and thank you for coming to this webcast, how to model aluminium composite material. Actually, this webcast came about really from a question I had on the support desk. We have a lot of customers who use this material for architectural cladding, as you can see in the image. And they were asking, well, how would we go about modeling this? So I thought I'd share that information with a wider audience in today's webcast. Aluminium cladding is mainly used on the buildings such as the images we've seen here. So this is a cladding which is made from aluminium composite material. If I just move on to my next slide, these images here just show the sandwich of material. So we've got aluminium on the outer and bottom of this panel and a plastic of some sort in the middle, and it can be supplied in different colors and coatings, and obviously there's an effect there of a wood effect on one of the panels as well. So that's typically what the composite material would look like. And moving back onto the slide I was on a second ago, just talking about how we would produce this, because obviously it's a folded sheet metal component, but on the other hand, in Solidworks sheet metal, we can only work with a uniform thickness, and obviously this has multiple thicknesses, in fact could even be multiple bodies. So how are we going to produce that in Solidworks? Now, one of the first things you could say is actually, do we need to go to that level of detail? You could actually just model it with the sort of the outer dimensions, but the bend details, sort of the bend radius and things like that in Solidworks, and try and maybe even ignore some of this detail. But if it is something you want, and you do want to go down to that, this is really where we're looking at for this webcast. How would we do that? So at this point, let's go over to Solidworks. And to save a little bit of time, I've just drawn up a panel. These panels are typically sort of mounted on buildings without any sort of fixings visible, so it might be some sort of hook or something like that which hooks over some sort of bracket which is mounted on the outer frame of the building. So this is a panel, and we're going to just create a base flange from that initially. So if I just go to my sketch tools, up to sheet metal, and I'm just going to create a base flange. The sandwich material, we're just going to say this is maybe a 5mm thick piece of material. So it's going to probably have, in this case, maybe 0.5 millimeter of aluminium, then plastic at maybe 4mm, and then another 0.5 mm of aluminium on the other side. So I'm just going to stick with that 0.5 mm there. I'm just going to go for minimum bend radiuses using a K-factor, but of course, as you're probably aware, you can use bend tables and bend allowance and things. That would all be possible as well with this. I'm just going to set the relief type to auto relief and tear as well on this. So really all I've just done is taken that sketch and applied a thickness to it. It's not folded or anything at this point. So the next thing I might need to consider is adding in the different layers. I'm just going to do that by creating a sketch on the interface. I'm going to use convert entities to convert the outer edge. Actually, in fact, I just need to convert the inner loops as well there. So let's just have those. And let's do an extrusion on that. And I'm going to make this a multi-body. So when I do this extrusion, I'm going to say it's 4mm to represent the plastic core. But I'm going to untick merge results. So if I just OK that now, what we should have, if I look in there, is it's considering these to be separate bodies. And obviously I need my final skin on here, so I'm just going to do the same thing again. Let's just convert entities on that, and let's just make sure we get these holes in here as well. And then let's just do a basic extrusion on that, and this will be back at 0.5mm again. And remember to untick merge results. So then we should have our sandwich. If I zoom in there, you could see our sandwich of material. So the next thing we really need to sort of consider, I guess, is we'd have to use a router, so maybe a CNC router, to machine out the grooves on here. And now I could do just an extruded cut or something, but I thought actually a good way of visualizing that would be to use a cutter of some sort. And we do have a tool under the swept cut tool. We can use a tool body. So So what you might want to do in your library, I've just added one quickly here on the right hand side of my screen. So if I just quickly go and find the one I've put together for this. So I've got some router bits I've just sort of modeled up with different profiles. Like maybe I'll just drag and drop one in here. Hopefully if I just place it and we'll take a closer look. So this would have more like a chamfered profile to it. If I just undo that, because that's not the one I wanted, let's go and find another one. I wanted the one which has a radius to it. So if I just drag and drop this in, okay, bear with me, I missed the fact that I was still in a sketch there. Just double check. Oh, I think I've somehow managed to not okay that last operation, so let's just quickly redo that. Untick merge results. Right, obviously hit undo probably too many times there. So if I just drag and drop this in again and just plonk my cutter in there. So this is the profile I want to represent as being my cutter. It has to be a revolved profile for this. Now I'm just going to locate it using some constraints here, because essentially I'm inserting a part into a part with this. So I want to add a coincident relationship maybe between that plane there and that edge there. Let's add that. And maybe that plane and this face will add a relationship there. And then I'll just do that there as well. So once I've got that into the position I want, I might just hide those planes so it doesn't look so messy on your webcast screens. So we can see we have, there's my tool, and I want to machine that along this edge here. So because it's going to be a sweep, I have to put a path in for that. Just to save a little bit of time, I've already put some sketches in for that. So let's just show the sketch I've already pre-drawn for this. Under features, I'm going to go to swept cut. I'm going to select a solid profile. The profile is going to be that tool body there, and the path is going to be this path here. So then I can select the bodies I want it to affect. Actually, if I just untick auto select here, really it's going to be this top body and that body there. It's not going to affect the outer skin at all. I want to keep all the resultant bodies from here, and you can see what it's done. It's machined that groove all the way along that path for me. So once I've done that, I can just maybe hide that sketch, and let's move on to the next profile. Obviously, as I said, this doesn't have to be this method you use. It could just be a simple extruded cut you use. Just for the purpose of this, though, I'm going to stick to the same method, and I've already put in some other bits, so I can only use the bit once for a profile, and if it was a circular profile I could come around in a whole loop. Actually, when I was sort of putting this webcast together, I did find for this particular operation I had to sort of run it as 4 separate cuts. So let's just turn on the next profile and do the same process again. Right, let's go with that. So that's got my profile going across there. And then let's come down the other side as well. So this is sort of fairly repetitive, I guess, for you guys at the moment. So bear with me whilst I go through these different cuts. I think I've got everything there. Let's just go through that. And then I've got one more, and that'll finish off the other side. Obviously, if it was a different profile, we'd use one of those other cutters for this. I just chose this sort of rounded off profile for this particular example. Later on, we will use another sort of more chamfered example and look at a slightly different method of creating that. So let's just bring that through and hit OK. So we've now got our panel, and it's got the different layers to it. Now I could at this point, because it is a multi-body and it's created a cut list for me here, I could come into here and actually set some materials. So I could come into here and pick the aluminium for that outer panel. What else have we got here? I'm just trying to route a bit so I don't need to do that one. Swept cut profile. So yeah, that would probably be one of the plastics. So let's apply a material to that. You can see how that's applied in. Let's just apply some material to this. I won't do all of them, but hopefully we'll get the idea. That panel there, sorry, I picked the wrong one. So apply the aluminium. So hopefully we can see here that we're getting the effect of those three cores coming through the model. So what ultimately we do need to do though is we need to turn it from 2D into a 3D folded up part. And how I'd propose doing that is using sketch bends. So if we just minimize that back down, once again, to save a little bit of time, I've created some sketch bends here. So let's just pick this sketch bend here. Under the sheet metal tools, we can select sketch bend. And we need to pick a fixed face. I'm going to pick the underside as my fixed face. And hopefully, let me just do that again. Now this definitely did work in practice, but I seem to be getting a slightly different answer to what I was expecting at the moment. Bear with me. There we go. 0.5 is using a way too big a radius for that. Let me try one more time. If not, I'll go over to it. It does work, I can assure you, because I've done it several times. So I can't seem to get that. It's typical of a live webcast. I can't get that to work quite as it should do. I can show you it does work. So to save on a little bit of time, we're trying to work out what mistake I've done there. Let's just quickly open up my finished version of it, and I'll show you back down through the feature tree. So this brings us to the point where I was, and what I did. I used a sketch bend here, and what it does is it just folds up that outer skin. Now the problem with that is, of course, the other bodies don't follow suit. So if I do the other fold quickly, you can see obviously the other skins haven't moved with it. But luckily in Solidworks we do have a tool called Move Copy Bodies, because these are considered to be separate bodies. So if I just show you how that would work, if I roll those through, in fact, maybe we'll just do one and I'll just quickly edit it so you can see. Exactly as when I inserted the tool bit in, I used the same tool. And essentially it's like having the assembly mates tool within the part environment. So I was able to reselect those bodies and mate them up with these edges here and reposition them. And you can see how they're now positioned accordingly. If I roll to the end here, what it allows me to do is then create a configuration. So I can have a configuration when it was flat and a configuration when it was folded. And that's one method of working on aluminium composite materials. If I just zoom into the corner there, actually with this particular example I haven't followed the profile through, so we could actually see if we didn't do the router cut all the way to the end, we would have an interference bit here as well. So that is an advantage, I guess, of modelling up the entire model. If we look at this model here, at this corner where I have applied the router all the way to the end, you can see how we don't have an interference fit. So that is one way we could look at doing this. If I just close that down, there is a second method I proposed as well when I was looking at this. So let's have a look at the method 2. So what we can do with this option here, actually I've just modelled this as a block here. I'm going to just convert it to sheet metal, so I'm going to pick my bottom face, pick my material and my bend edges. You don't have to model it like this, you could model it using edge flanges and just trying to get the basic shape as quick as possible. And then what I could do is an unfold operation on it. Actually, in fact, what I could probably do is just cut those cutouts through it as well. So if I just cut those out, like so. So what I'd then do, is an unfold operation. So if I do unfold, pick my fixed face, maybe that'll be the bottom face here. And that flattens the model out. So this time what I might choose to do is add the material onto the panels themselves. Now for time reasons it's only a short webcast, I won't do all of it, but what we could do is pick that face, create a sketch. In fact, in this case, let's do offset entities. I want to reverse the offset, maybe just a nominal amount of 0.5 mil. Now, when I was testing this, I found that if I converted entities and added the thickness of material directly on this edge, it failed to fold. So I did need a slight offset at this point. And let's just do an extrude on this. Let's just set that to 4.5 mil. Now, of course, on the edge detail here, we would actually have that maybe a chamfer detail, depending on what tool we'd used. So let's just use the chamfer tool on here. I'm just going to set the distance at 4.5 mil, so it's consistent all the way around. So you can see how I've added the material thickness there. Let's just do it on, I'll just do the same on this edge here. So if I created a sketch there, let's just do a convert entities on that one. I want it to marry up with these two edges here, but it's maybe just this edge here which needs to change. So I'll just come in and get rid of this relationship here. I can then move the sketch line up. Put a dimension in to control what offset I want, so we'll just keep it consistent with 0.5 mil maybe. And do the same with that. This time obviously I am merging results, I should point out, rather than the method I used previously. Right, so this method here is assuming that we're using like a V-groove cutout. The advantage of that, if I come over to my sheet metal tools again and do a fold operation, collect all bends, you can see how it has folded it up using the sheet metal functionality this time. I haven't had to create two configurations manually here. Now, with this method, I guess the disadvantage is I'm not representing the three layers of material. One way we could work around that is to do a split operation whilst it's in the flat state, and then apply different appearances to it when we fold it back up, or whilst it's in the flat state. If I go to my finished version of that, because I did have to apply them I applied the plastic material to the main core, and then I applied the aluminium appearance to the finished outer faces. If I just come in and take a closer look here, this option here, as I said, whilst it was in the flat state, if I just roll back the tree, I've done a split operation. So all I've done here is I've just dragged two sketch lines through the model at the correct offset values to represent where the aluminium would be. Used the split tool. I've then done the fold operation, which we just saw, to fold it back up. And then I've just gone through using my appearances of aluminium and the black appearance as well to represent the core plastic in the middle to represent that as well. So that's sort of two different methods we could employ to represent aluminium composite materials. So really going back to my PowerPoint here. So method one, model the outer skin as a flat panel and a base flange. We then modeled the other layers as separate bodies. I machined the grooves in using a cut feature. In my case, I used a tool body cut with the sweep cut tool, but it could just be an extruded cut. It didn't have to go to that detail. We can then create new configurations for the folded and unfolded version. And I used sketch bends to fold up the outer skin. We then used move copy bodies to reposition the internal layers within the folded and within the folded version. So we had two configurations. The other method used more core sheet metal functionality. We did have, the key thing was we did have to put a slight offset in when I did the extruded feature on the internal faces. I did need a slight offset on those internal edges. But then I was able to use the refold tool to fold the material up. And then if we wanted to represent those different layers, I used a split tool and graphically represented the different layers of the material using the appearances. So I guess in terms of if you were after the actual mass of the item, you get a much more accurate result with the first method because we've actually got the separate bodies there. We've been able to assign the different materials to it, whereas in the second option, we're more graphically representing it. So that really brings me to the end of the webcast. Are there any questions at this point?